Number 5. We had to zoom out a little bit here. But A, what information is given by the magnetic quantum number? The magnetic quantum number gives us the orbital's orientation around the nucleus. The angular momentum quantum number gives us the shape, right? Sphere, dumbbell, clover. The magnetic quantum number tells us how to orient that shape in three-dimensional space. So as we go to B, how many orbital orientations are possible for each of the S, P, D, and F sublevels? Well, for S, it's a sphere. The shape is a sphere. And so there's only one way that you can orient a sphere. It's that it's a sphere. You can't move it along the x-axis or the y-axis or the z-axis and have it be anything but a sphere. But when we move to the P sublevel, those orbitals are shaped as dumbbells. Okay, there are 3 different orbitals, each of them shaped like a dumbbell. And so you can definitely imagine having the dumbbell run along the x-axis, have it run along the y-axis, and then having it run along the z-axis. And so there are 3 different ways to arrange those 3 p orbitals in 3-dimensional space. As we go to the D sublevel, there are 5 d orbitals. There are 5 of them. And so there are going to be 5 different ways to arrange them, to orient them in 3-dimensional space. For the F sublevel, there are 7 F orbitals. And we're going to have to orient them in 7 different ways. For now, that's just going to be memorization. Okay, there's 1 s orbital, there are 3 p orbitals, there are 5 d orbitals, and there are 7 f orbitals. For C, explain and illustrate the notation for distinguishing among the different p orbitals in a sublevel. So we're talking about a p sublevel, so there are 3 different p orbitals within a sublevel. We use subscripts to indicate the various orbital orientations possible in terms of the x-axis, the y-axis, and the z-axis using that XYZ 3-dimensional coordinate system. Now, that 3-dimensional coordinate system is going to be centered around the nucleus. So the nucleus is always going to have to be at the center there. We use p sub x to refer to the p orbital that's in the x-axis or in the x-plane. We use p sub y to represent the p orbital that's on the y-axis or in the y-plane. And then, you guessed it, we use p sub z to represent the p orbital that is in the z-axis or along the z-plane.